Alright, welcome back. Today we're going to be talking about dimensional analysis. So what is dimensional analysis? It is a systematic approach to problem solving. Systematic means we are going to do the same system every single time. That uses conversion factors to move or convert from one unit to another. So we are going to use the conversion factors that we learned about in the last video, the metric conversion factors. So you want to have that data, those conversion factors nearby. You should have those written down in your notes. You're going to be able to look at them all the time. You'll need to have them memorized by the time that you take the Chapter 2 test. So, two simple math problems, multiplying and dividing. So we're going to be using conversion factors, and what a conversion factor is, it is a ratio of equivalent values having different units. So a conversion factor that we talked about in the last video is the fact that 1 meter is equal to 1,000 millimeters. So that's how I normally write it in my notes or on a conversion table chart, but what I'm going to write this as is as a fraction, as a conversion. So I can write it as 1 meter divided by 1,000 millimeters, or I can write it as its reciprocal, 1,000 millimeters for every 1 meter. So, when we are writing these conversion factors, we know they are derived from equality relationships. So, a dozen eggs is 12 eggs. Percentages can also be used as conversion factors. They relate the number of parts of one component to 100 total parts. So, if you have a 97% average, what that means as a conversion would be 97 over 100. So how could I use these as conversions? If I see that it says 25% by mass solution, what I'm going to read that as a conversion is 25% means 25 out of 100. So I would use that as a conversion. So that would be 25 parts, and 100 is the whole. So that would be part of the fraction. And then I look at my second one right here. A density of 1.2 grams per milliliter. So remember that density is the amount of mass per unit of volume. And so right here it says 1.2 grams per milliliter. I'm going to rewrite that as 1.2 grams per milliliter. And remember, mathematically, anything divided by 1 is just itself. So the way that I'm going to actually rewrite this as a conversion is going to be 1.2 grams per every 1 milliliter. So these, the way I've written them right here, can be used as conversion factors because they are written as fractions. I could also flip it and use the reciprocal of 1 milliliter for every 1.2 grams. I can do that for the first one also. So, conversion factors can be used as the reciprocals. You have to pay attention to the units. So right here it says a 5% NaCl solution contains 50 grams of NaCl. What is the total mass of the solution? So there's multiple ways I could do this, but if I'm going to set this up as a dimensional analysis problem, what I'm going to do is I'm going to start off with what I'm given in the problem, is that I have a 5% NaCl solution. I'm going to rewrite that as 5 parts over 100, which is the whole or the total. So if it's a 5% solution, that means that there is 5% sodium, NaCl, sodium chloride, per 100 grams of the solution. So what I can do is set this equal to each other. I can also say, okay, I have 50 grams of NaCl, and I'm going to use this as a conversion. Well, I want to be able to cancel out NaCl. So I'm going to put grams of NaCl right here, and I want to figure out what is the total mass. And so the total mass right here, I'm going to take my conversion factor that I wrote, and I got 50 grams from the problem. I'm going to take this conversion factor that I wrote right here, and I'm going to put it in the problem. But I have to pay attention that my units match up. So in the conversion box, it says 5 parts per every 100 total. But that's not what I need in a dimensional analysis problem. I need the reciprocal of that. So I need 100 parts total for every 5 parts. So I'm going to put 100 down here and 5 below it. So because of that, then I'm going to do 50 times 100 and get 5,000, and then divide that by 5 and get 1,000 grams total. So the reason I did that is that cancels out my mass of sodium. I can go back and check it, and I can do 50 divided by 1,000, and when I multiply that times 100, it gets me at 5%. So that is a 5% solution. So that's how I can use dimensional analysis. I can use conversion factors for percent. But sometimes I need more than one conversion factor. Sometimes I need conversion factors that are things that are generally known. So right here it says how many seconds are in a week. So I can I go directly from seconds to week? No. But what I could do is go from seconds to hours, to days, to weeks. So if I'm going to do that, I'm going to set it up as a conversion, and I'm going to start, actually I had it backwards, so I'm going to completely flip all of this around and go backwards. And I'm going to start with 1 week. You see why that was a mistake. If I could figure out how to erase, I would. There we go. So I'm actually going to go week to day to hour to seconds. Apologies. So I'm going to drop weeks down here to days, and then I'm going to go from days to hours, and then hours to seconds. So we know these. How many days are in a week? There are 7 days in 1 week. How many hours are in a day? There are 24 hours in 1 day. And there are 60... Oh, I'm sorry. I can't go from hours to seconds. I would have to go to minutes. And then I would have to go to seconds. So what you're seeing right here is what a lot of people make mistakes, and as you can see, they're really easy to make if you aren't careful. So make sure, I've been teaching chemistry for 6 years, make sure that you pay attention when you're doing this. So right here, now I've got the right number of conversion steps. I've gone through, corrected my mistakes. So what I'm going to do is figure out how many seconds are in a week. So I'm going to do 1 times 7 times 24 times 60 times 60. And I'm going to get that there are 604,800 seconds in a week. 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 604,800 seconds So that is how we do dimensional analysis. And next time we are going to talk about how to use our conversion factors. And we know that they have to cancel units. So next time we're going to talk about how to use our metric conversion factors.